Welcome to the Personalized Medicine Podcast. This is the place where scientists, clinicians, and entrepreneurs discuss the progress of this rapidly developing field. I am your host, Oleksandr Yagensky. Let's start. Three, two, one, and we are live. Welcome to the next episode of the Personalized Medicine Podcast. On this episode, we are re-entering the topic of genetic data management. My co-host Louisa has done a great interview on the DNA data privacy with Dr. Rachel Hendricks-Stirrup for episode 7. Make sure to check that one. Today, we are approaching this topic from a slightly different, entrepreneurial angle. And I am very happy to welcome today on our show Dr. Mark Hahnel. Mark is a biologist by training. He got his bachelor degree at the University of Newcastle and then moved to Leeds to complete his master's in human genetics. He continued his journey in biomedical research at Imperial College London, where he did his PhD on stem cell mobilization. While still doing his PhD, he founded Figshare, a company that enables scientists to share their published and unpublished data more effectively. In 2017, Mark teamed up with Aldo de Pape, and together they co-founded genomes.io, a personalized DNA databank that allows consumers to take control of their own DNA data. These are two very exciting companies, and I hope to learn more about them today, and I'm very much looking forward to this conversation. So, Mark, thank you very much for accepting our invitation and being today with us on the show.
Thank you for having me.
Perfect. Let's start with genomes.io. When I first seen what you guys are doing there, I was really amazed because this is not something that you typically see in the world of consumer genetics startups. Perhaps you can tell our audience what exactly is what you do at genomes.io and how has it all started?
Sure thing. I think a good way to do that would be to start with how it started and highlight some of the areas in which we saw a problem. And then I can talk a little bit about the technology that's come together at the same time. So as you just mentioned, when I was doing my PhD, I started a company called Figshare. Figshare is a place where academics can publish any of their research outputs, regardless of what file type, what size. So the idea there is primarily around data, upload a data set, add some metadata, publish it, get a DOI, track the impact. That's the basics of it. So that started in 2011. And if you caught me around 2011, 2012, the message I was very big on preaching was all academic research should be openly available. If the data is there, we can build on top of what's gone before. Academia, drug discovery works. We get drugs, but if the data is made open, we could move a lot further, a lot faster. And I think that's been acutely emphasized in recent times with trying everybody opening up research in order to build on top of it faster with what's been going on with COVID-19. So, as I say, back in nearly a decade ago, I was very much, there is no reason why you shouldn't open any of your data. Since then, the European Commission has come up with this line of as open as possible, as closed as necessary when it comes to research outputs. And that's because not everything can be made openly available. For some things, that is, you might have commercial agreements with the funding of your research, and they have a right to first run at it, so there needs to be some privacy. I understand that, but also there's this idea that there's a lot of data that shouldn't be made available because it's exploitable. And the perfect example of this is in genomics. So as all of your listeners, I'm sure, know, the human genome sequenced in 2001 for the first time, and since then, the race to zero on costs has meant that it's become a lot more affordable, a lot more people have had it done either direct to consumer or in some studies. And I first saw people sharing their children's genome through Figshare. And at the time, I thought, I'm not sure this could surmount to child abuse in the future. Where is the ethics here? It's a very grey line. And then since then, we've seen ways in which genomes have been exploited. It is your most personally identifiable data about you that you have. It knows more about you than you know about yourself. And so around 2016, 2017, it was one of these conversations that we'd have in the pub with one of my good friends who'd worked on Figshare in the past and then gone his own way, Aldo. We'd talk about there must be a way to better handle genomic security, to still realize all of those potential benefits of personalized medicine, but to put the end user in control of their genome and not somebody who doesn't care or somebody who cares deeply and intends to sell it. And so a few bits of technology came together then at the same time. Obviously, the price of whole genome sequencing is now dropped below $300. Whereas 10 years ago, exome sequencing was coming to around the $100 mark. But there's also been advances in ideas around repeat consent models, repeat consent to data, using blockchain. That was just coming into the forefront. There's a lot of talk around ways in which you can query data in an interesting way. Homomorphic encryption is big on the scene right now, although it still needs some developing out, I'd say. And then the ability to secure research data or secure any files in encrypted vaults has been something that's been pioneered by AMD, who we've partnered with. And so Genomes.io is basically secure genomes at the individual scale that allows repeat consent, repeat access to query the data, so you still get all of the benefits, but it's controlled by the individual. And so it's a very simple idea on first look, but it has lots of potential in terms of ways in which we query genomes going forward.
Understood. Yeah, that sounds really exciting. And the idea that you can and actually need to protect your own genetic data is very important, especially as you mentioned in this age of widespread consumer genetics. So I would like to ask you a bit about the technology that is behind your platform. How can you ensure that the data of your customers are protected and that they, the customers, are indeed in the control of their own data?
Yeah, so the way it works is the genome is sequenced. We have an auditable log of the genome sequence where we can work with partners all over the world. So we have signed contract with several genomic sequencers. They never find out who you are. And the file, once generated, is uploaded into a DNA vault. So your own personalized vault. So basically, the genome is sequenced and put into this secure, it's AMD-SEV is their term of their new bleeding edge technology, which locks up the data. And then the workflow that we have allows the individual to connect to that vault, but nobody else can connect to that vault. And the way that works is using essentially, for those more familiar with blockchain, a blockchain wallet, so a private key. So you download an app and you connect it to your vault, and then only you have access to that vault using approvals via your private key, which is usually a secure messaging system from your phone. And the parallels I like to think of there are, people say, well, you can always get more secure, you can always do more security, and we'll keep working to ensure that is the primary goal. But this idea of, when people lose the keys to their Bitcoin wallet, nobody goes in and gets access to that money. You've heard the horror stories because of the security controls that are once you lose your private key, you don't have access to it. So only those with the private key can access it. What it also allows is it means that anytime you want to ask a question of your genome, it needs to go via the individual. And this, when you scale it up, gets very interesting because we are sequencer agnostic, we are government agnostic. All we are is a layer of technology, which is where the file lives and how you access the files. So if you imagine a world in 2025, as the market predicts that 1.2 billion people will have had their whole genome sequenced, then in theory you have access to 1.2 billion people who you can ask many different questions from. If we look at the one on the doorstep right now, COVID-19, do you have symptoms, and can we ask a question to see if you express this gene, because we know that was related to susceptibility to SARS. So you could ask that question of 1.2 billion people very quickly. Whether they answer the question is another thing, but it's a new form of technology that allows you to reach people in a way that hasn't been available in the past.
Right. And those numbers are really stunning, what you just mentioned, 1.2 billion people who will have their whole genome sequenced by 2025. That's not such a distant future, and we better be prepared for it. So I also want to ask you, what are actually the benefits for your customers to go through your genetic testing? What kind of result, what kind of output can they get already today from those genetic data, and perhaps what can await them in the future?
Yeah, that's a great question. So it's an interesting time when it comes to people's awareness of genomics. Obviously, if that was the area you researched, it seems like it's not moving fast enough. But the flip side to it is that a lot of people are still not aware. And so this idea of huge numbers of people getting their whole genome sequenced and awareness levels, it's a really interesting juxtaposition, because you have something like 25 million people have had their 23andMe or their Ancestry.com done to get their exome sequenced, and because they're inquisitive about it. But if you are a premature born baby in North America, or if you're born with a rare disease in North America, the first thing they do is sequence your whole genome, because the insurance companies, it's a lot cheaper. The return is 27 times cheaper to treat a disease if you know the genomic basis of it. And so if you are born with a rare disease and they're looking to diagnose it, they'll sequence your whole genome as a baby. Where that data goes, we're not 100% sure. It's basically the insurance companies paying for it. So if the insurance companies are paying to find out exactly what your genetic condition is, then that's very exploitable in the future. This idea that they can say, well, you're not going to get health insurance because we know you've got a genetic disposition to heart disease or depression, or some things that might not even phenotypically be expressed. And so as there's a lot of people going to be getting their genome sequenced without knowing it, there's also things like in the UK right now, where I am, we have 5 million people getting their whole genome sequenced by Genomics England, donating it to science. And that's great, because it's good to see that in the culture, that people want to donate information to a good cause. I think the risks involved there are not really written out to these folks. The fact that it's not just your data you're giving away your family's data. There's also the idea that 96% of publicly available genomes to study are Western European or North American, so basically white. So it's a very homogeneic population that we're looking at and basing all of the drug discovery that we do on. And so there's this. If a lot of people say, well, isn't it too early for genomics? Isn't it too late for genomics? Has that ship already sailed, or is that ship not sailing for the next few years? And so, to come back to your question about where we are right now and what you can get from these workflows, with this idea of public interest, I want my genome sequenced. and I want to find out information about myself. So on the genomes.io front, the idea that you can do that and you can lock your genome in a vault, of course, as part of that package right off the bat, you get your ancestry and some inheritable characteristics and markers for disease, which is pretty much what you'd expect with the 23andMe or the Ancestry.com tests that you may have done in the past. The difference being that 23andMe has sold that data to Genentech or GlaxoSmithKline already, and you don't see any of that money. So one of the things we can do is broker your data with big pharma or interested research communities who may want to ask a question of your genome, and in exchange you get some monetary reward for it. But again, you control the keys. You'd have to authorize it. It would be anonymous. It's not throwing the whole genome out. It's just asking questions of the genome and returning an answer that will not disclose too much so that your anonymity is questioned. And then there's a lot of stuff that's going on now that would be applicable to making life a lot easier for you going forward. So right now, there's algorithms that query your genome to say whether you are genomically predisposed to breast cancer. So 75,000 women in North America have had this test done. It's very expensive because the first thing they need to do is sequence your genome. They then either keep the genome and do something, maybe sell the data, or it's thrown away, and next time you need a test done, you have to spend the high amount of logistics costs and cost to get your genome sequenced. So what we can do is, if you already have your genome sequenced, we can allow third-party queries on top of the platform itself. So third-party apps, almost like an app store on top of your genome, where that company could up their revenue margins, but still provide a great service for a less cost for the consumer. And I think thinking further down the line, we already have the way in which genomics plays a role in how fast you process different drugs. Every drug dose you get is the middle of the bell curve, because that's the average dose that people need, but you might process it very fast. And if it's pain medicine and you process it very fast, you might need to up your dose, and you can ask questions of your genome to find this out. And so in the future, I see folks walking into, if I walked into a doctor's in North America and they wanted to prescribe me a drug, I could ask a question of my genome and see how well I responded to that drug, or vice versa. But that is heading towards the 5 years from now.
Right, but that's a very exciting and promising future. And what you just mentioned would truly enable personalized medicine, because patients will be in control of their own data, and then B, will hopefully have more research done to actually link those different genetic variations to specific responses to different drugs.
Yeah.
And I would like to go further on one of your last points. So you said that essentially we can simplify data logistics with genomes.io. And are you thinking about actually integrating more data inputs into your platform? Because it is important not only to understand the genome, but perhaps what are the symptoms that this patient has been experiencing over the last years, and how can we then combine different inputs to provide most clinical value to that person?
Yeah, exactly. I think the primary part of it here is this idea that, as you were just referring to, that the idea of personalized medicine, having your genome in your pocket at all times, it can't be a bad thing when it comes to medical situations. When it comes to, if you're rushed to hospital and you've had your genome sequenced by Genomics England, that's really of no use to you, because you don't know where that data is. You don't have access to it. There's no way to query where my data is. You may have it downloadable somewhere, but on your phone, queryable is a great place to be. And so this idea of having your genome in your pocket combined with more data about you becomes infinitely more powerful in several ways. It's a lot more powerful for research going forward. And I think this is very interesting in terms of the potential for monetization or the potential for drug discovery. You can think of many scenarios that are mutually equitable for advancing research that can be freed up using this workflow. So if you can provide some phenotypic information and have that securely stored but queryable, then you can do some really interesting things with GlaxoSmithKline wants to query males aged 18 to 35 in sub-Saharan Africa to see if they express this one gene that they know interferes with their drugs that they're trying to bring to market from Europe. To do that, normally they'd have to spend a lot of money doing a clinical trial, involve lots of people, it costs tens of millions of dollars, whereas now they can just say, hey, if you fit these parameters, you get a notification on your phone that says, GlaxoSmithKline is offering you $50 if they can ask this query of your genome. This is the only information they'll get. They won't find anything else about you. Do you want to grant them access? And money is going to be a different kind of driver in different parts of the world, but you can imagine that scenario is a win-win-win for everybody. The question about tying this data to, again, going back to the COVID-19 stuff, the idea of having people tracking over time. Here is, you can ask questions of my genome, and I have had COVID-19, or I don't think I've had COVID-19, can help answer questions faster. But there's also this idea that with the more information that you have, you can find a perfect subset, particularly with things like rare diseases. Rare diseases is an obvious first focal point for us because the logistics of getting your whole genome sequenced aren't very easy at the moment. There's only a few places that you can get it done. Most of them have it in their website terms and conditions. Their business model is to sell your data. So they'll give you a nice low price and then sell your data. But if you can have your genome securely stored and then provide information that allows those rare disease development groups or rare disease pharmaceutical companies to query that data, then these are groups of people who are looking for a cure, and they'd happily give away the data. The problem at the moment is the logistics of getting their genome sequenced and the logistics of having 1,000 people in Europe who have the same genetic disorder, adding information on their symptoms. So the starting point is always 100% privacy. And then depending on trusted third parties, you might not trust the pharmaceutical companies, but you may trust the rare disease organization to grant access and have a key for you as well, which really opens up the door to allowing people to move faster with this. It's got some really nice little, for the academics amongst your listeners, it's got some really nice little tweaks as well, where if you need ethics compliance for publishing a paper, using the blockchain proof of work stuff, you can get to a point where proof of execution stuff where it says, I asked 20 people this question of their genome. It executed the query. It returned this data for me without ever giving up their anonymity. But what we have here is we have a signed, auditable log that says 20 people did have their genomes queried, and this is the results that it gave. So you have the signed approval for the ethics of that workflow. And you can do it over and over and over again, as opposed to this. What's often the case is people get their genome sequence, can't access it, never able to link that data again. So that repeat consent model is really interesting for that genotypic-phenotypic mix.
Yeah, absolutely. It simplifies the entire logistics of research, and I guess it's beneficial for both parties, for patients and for the academics.
Yeah, it has the potential to be.
We are doing this show for you, and your feedback is very important for us. So if you have any suggestions or comments, would like us to cover a specific topic or recommend a guest, please write us an email to team@pmedcast.com. Or you can reach out to us on LinkedIn, Twitter, or Facebook. Just type in Personalized Medicine Podcast and you will find us there. To download the show notes for this episode, visit our website, pmedcast.com. It's pmedcast.com. The show notes include guest bios, links to their most notable work, and recommendations for additional reads on the topic of the episode. Make sure to check them out. And don't miss the next episode. Subscribe to our podcast on your favorite podcasting platform. Give us a rating and leave a comment. It will help us make this show better. And now, let's get back to the interview. Let's move towards the next topic that you already briefly mentioned. With genomes.io, you allow your customers to monetize their own data. And you mentioned that pharma companies are very eager to work with that data. So maybe you can elaborate a little bit more on why exactly pharma companies are actually fighting to get access to that data, why they are so precious, and how your customers can leverage their own data for some own profit.
Yeah. So as mentioned, there's a lot of information in your genome. We're finding out more every day. There's $10 billion of research every year goes into querying genomes and finding out anything from, these are the markers associated with depression, all the way up to, there's a paper on, this is how tall you're going to be, all things considered, which is remarkable to me, within an error incidence of kind of 2%. So this is all fascinating. It's also exploitable. And there's a lot of stuff that you want to keep to yourself. So the pharmaceutical companies are very interested in this idea of, I think the pharmaceutical companies are very going into this with the right intentions. The more information they have, the better data-driven decisions they can make about their drugs, so that by the time they go to clinical trial with things, they're not spending hundreds of millions of dollars on things that they already know are going to have problems because of some efficacy issues or other things that are happening at the genomic level. So that's really powerful. Obviously, the problem here is that the exploitation can come from many different areas. The idea that they were going to sequence the genomes of the children who were separated from their parents in North America under ICE for trying to gain access to the country. This sounds like a good way to stop losing children. It's strange that you'd lose children in the first place. But of course, giving Donald Trump access to hundreds of 3-year-old genomes with the idea that he doesn't want them in the country, that's only going to be used for bad in the future. It's not going to be used for a positive way. And so,
right.
And so this idea with working with the pharmaceutical companies, our first assumptions thought that we had were based on conversations we had where a populace of 10,000 whole genomes is where it's really interesting for these big pharma companies. But we also find that these smaller there's rare disease pharmaceutical companies who are looking for drugs for those, thousands of people in the world who have a particular disease, because their business model allows them to, if you work out a positive business model that means that they're curing or treating a disease, and B, they can make money on it. So again, a win-win situation. 30 million people in Western Europe have a rare disease. So rare disease is a bit of a misnomer, but the idea that these people want to be treated but how do they get connected to the research groups? And how do these research groups who may not have a genomics background get access to whole genome sequencing at the individual level? And so I think this is an area where in 10 years, we'll look back and say, well, why weren't we doing whole genome sequencing on every rare disease patient in the UK? And it's concerns about privacy. It's concerns about how that data will be exploited in the future when that patient is treated and lives a healthy life. Then, well, their kids, any kids, brothers, sisters, their data is being released with that as well. We've seen that with the Golden State Killer and people finding killers by querying their brothers and sisters' genomes. So there's the other side to this is that there is potential benefits, and there's a very big, if you've done nothing wrong, why should you care about your genome being out there? But there's so many ways in which there's bad actors in the space who will take advantage of it, that does not outweigh the bad that can be done there.
Yeah, absolutely. And probably we still are not aware of those kind of malicious ways of using our own genome data for to create some problems later on in the future.
The horror stories write themselves. There's one a week. There's people being deported from Canada. There's people being refused life insurance, health insurance. Even though it's illegal to do that, you still have cases of that. It can, you pull on some threads and it can extrapolate out into some really bad stuff.
Yeah. So that means it's really very, very important what you are guys doing with genomes.io. So I still want to reiterate on that point that you mentioned about data monetization. So how can consumers actually leverage that data for their own profit?
Yeah. So the way we think about it is it's a DNA bank. You put your DNA into a vault and it earns interest for you. This also brings up some really, really fascinating economics and ideas. So, as I mentioned, you can imagine the scenario where you get a notification on your phone, GlaxoSmithKline, because your private key is on your phone, your access control is on your phone. So GlaxoSmithKline would like to ask a question of your genome. This is the question they're going to ask, and they will pay you, say, $50 for that bit of information. All explained, what you're giving up, how this is not re-identifiable back to you in any way. And so what GlaxoSmithKline come back with is thousands of data points that would have cost them millions in the traditional model to get. So this is the idea that you can have this win-win where GlaxoSmithKline are paying a lower price to get their data points. The individual takes the large chunk of that money. Our business model is that we take a small percentage of every query that is made on every genome. So that scales up very interestingly if you have, 1 billion genomes being queried every week, then the revenue models make it a very sustainable business. But at the end of the day, the lion's share of the revenue goes to the individual. Again, this makes really interesting ideas about if you imagine your genome is stored away in a bank and you're making interest on it. The day you die, you can just pass it on to your kids, and they can continue to make interest on it as the research continues to find more things, as it gets more interesting. The idea there as well of these third party apps, people building algorithms that can tell you more about yourself, and you either if you're interested to know that, you can query your genome, and it might cost you 20 cents to run this new report, which previously would cost you a lot of money or wouldn't be available through your national health.
Yeah, it's a very interesting concept of thinking about your DNA data as essentially as a currency. And I guess you guys hit the chord with that idea. But I also want to ask you, how difficult or how easy was it for you to convince investors at the beginning of your journey that this is something that is actually doable and makes a solid business case?
It's really interesting to see where the different areas of interest were with investors, as you can imagine, and some of your listeners, I'm sure, explaining your research to your parents can often be a complicated thing and a skill in itself, because often the research that you're doing is so complex. You want to make it as easily digestible as possible, and this is the case with even life science investors. They know about certain areas. Their focus may be, I don't know, proteomics or novel drug discovery, and so this idea of genomics is understandable to a level, but it might be quite shallow. So we've had to explain what a genome is to folk. We've had to explain the benefits and why genomics has been touted as the revolution point in personalized medicine. But once they get past that, there's often things that, as humans, they can find relatable. So people, as I mentioned, who have that one thing that's genetic, my joints lock up and I'd really like to be able to help provide that information to people, because at the moment I'm sat here as an investor and I don't know how I provide information about myself to pharmaceutical companies who can then provide a drug for me so my joints don't lock up. So it was often finding parallels where people knew of something or understood this concept of genomics as it being affecting themselves or people they knew personally. And once that was clear in their mind, then it becomes very interesting, and people very much buy into the idea of where this is going. The idea that genomics sequencing companies are already billion-dollar companies, lots of them, also helps with this idea that this genomics isn't going away. It's not a fad. And so if you explain the benefits and then where we are right now, as I say, for a lot of folk, it was, where are we on the zeitgeist? Is this everybody is going to get their genome sequenced, or is it just going to be a hobby project for people who like their 23andMe? And so once people understood the long-term benefits of genomic medicine, then highlighting to them the current state of play is really what brought it home. I mean, as I mentioned, you can have a conversation with an investor, and the next day you can read online that people are going around in California offering people $20 to swab their cheeks so they can get their genome sequenced and sell it to data companies. There's literally horror stories every day, and so that's very powerful in getting that message across.
Yeah, that's really nice to hear. And I'm very glad that you guys found some great investors to back you up on this very important mission. I think it is also a very good transition to the last question I would like to ask you. And this is the question about the future. So I would like to take an outlook with you into the next 10 years and ask, what are the 3 developments that you would like to see in the world of consumer genetics?
Yeah, perfect. So I think there's lots of things that can happen. The 3 that are standing out for me is the idea that everybody is going to have their genome in their pocket. That's the world change when that happens. Having access to your genomic data in your pocket, everybody will have that. If we think about this idea of by 2020, 5 million people in the UK are getting their genome sequenced by 2023 by the UK government. That's 1 in 10 people. That's the point where it's in your family. So the awareness level of everybody getting their genome sequenced is the first step. Somebody who's had their whole genome sequenced. And then the second level of, this is great, everybody has access to their whole genome in their pocket. That changes the face of personalized medicine in a lot of ways forever. The other thing that's always going to be happening is new research into your genome. As we mentioned, we're less than 20 years in to having the full human genome sequenced. And so we're always finding out more. Again, there's a new discovery every week in Nature Genetics or something saying that these markers are identifying certain conditions. So we're going to learn more about ourselves. And while it's also always fun to learn about, your ancestry, where that might be interesting, the stories that tells, the most important breakthrough so far with this direct-to-consumer genomics for me was being able to identify that I was a carrier for a disease, because that has direct implications in the way in which I plan my life going forward. And then I think the final thing is by locking down the data at 0.0, that's a very binary thing to do. It's like, okay, we're going to lock it down and you can ask questions of it. I think the nuance with which we're able to ask the questions and the way in which that develops out is going to be the third pillar on how this technology rapidly advances, because we've spoken with a research group at the Turing Centre in London who are looking at how much can you query a genome before you give away too much information. So this idea of GlaxoSmithKline wants to find out this. I use GlaxoSmithKline as big pharma company X, by the way. Sorry, it's interchangeable. Pfizer want to ask this question and they want to find out this information. So we can then work with them to make sure, and the group at Turing to make sure that this is not revealing too much information. So it maybe it's broken down into multiple queries, and so the privacy is maintained. I think the next level of that is using things like homomorphic encryption, which is being developed at a fast rate, but it's still just on the brink of being really interesting to the space. But the idea of doing much broader genomic studies using new encrypted ways of querying data is where I think we'll be able to move at a very fast rate, and there is no blockers in the way of advancing research whilst also taking care of that number one thing, which is maintenance of the individual privacy so they're not exploited, and those that are most risk of being exploited are not exploited, all at the same time making some money for themselves in the process should they wish to do so.
Perfect. So the future looks very exciting, and I also believe very realistic. These are all very attainable goals. So, Mark, before I let you go, can you let our audience know where can they find you online if they want to reach out?
Yeah, you can find us online at genomes.io. It's not the most imaginative name, but you can find us on Twitter, Facebook, Instagram. The handle we go by is at genomesio.
Perfect. Mark, thank you so much for taking our time and talking to me today. It was a fantastic conversation that we had.
Thanks a lot. Appreciate it.
Thank you so much for being with us today on the Personalized Medicine podcast. If you like this show and know someone who would enjoy it too, please share this podcast with them. And don't miss the next episode yourself. Subscribe to the Personalized Medicine podcast on your favorite podcasting app. You can find us on Apple Podcasts, Spotify, Pocket Casts, Stitcher, iHeartRadio, and many, many more. Please rate us there and leave a comment. That helps us to grow and deliver the best experience to you. To access the show notes for this episode, visit our website, pmedcast.com. It's pmedcast.com. And engage with us on social media, where we regularly share the news and exciting content on personalized medicine. You can find us on Twitter, LinkedIn, and Facebook just by typing in Personalized Medicine Podcast, or use our handle, pmedcast. And if you have any feedback or would like to suggest a guest for the show, write us an email to team@pmedcast.com. Have a great day, and until next time.